of Engineering and Technology. This video I am going to present single phase induction motor. This video contains introduction of single phase induction motor. That means here we have discussed what is single phase induction motor and where it is used, and also we have discussed construction, working principle and starting methods of single phase induction motor and comparison and applications of single phase induction motor. Let's see one by one. First, what is single phase induction motor? Based upon the supply, motors are classified into two types, DC motor and AC motor. The AC motors are classified into two types based upon the type of AC, whether it is three phase or single phase. If we have used single phase, means it is called single phase AC motor. Three phase means three phase AC motor. Okay, here we have discussed the single phase induction motor, then AC motor that operates on a single phase power supply. Unlike the three phase induction motor, normally motor means it converts electrical energy into mechanical energy using the principle of electromagnetic induction. In this motor, the rotor receives no direct electrical connection. Here current is induced just like a transformer. This motor operation based upon the transformer principle. So this motor is also called as rotating transformer. It is widely used in homes, light industry, fans, pumps, compressors, washing machines, mixers, etc. Most of the home appliances and industries we have preferred single phase induction motor. Similar supply requirements makes it ideal wherever only single phase power supply is available. Normally, the single phase induction motors are commonly used in the most of the home appliances. Okay. Next, single phase induction motor, we are giving the single phase AC supply, so it is called as a single phase induction motor. If we are giving the single phase AC supply, it produces a pulsating magnetic field. The pulsating magnetic field can be resolved into two equal and opposite rotating field. That is, the two rotating fields are created. One is a forward rotating field, another one is a backward rotating field. At standstill, both fields produce equal and opposite torque. So, equal and opposite torque means the net torque becomes zero. If the torque is zero, means the rotor cannot start on its own. So, the rotor is not a self-starting. So, we have to make some arrangements, some extra arrangements in order to make the motor becomes a self-starting one. Once given an initial push, the motor keeps rotating in that direction and develops torque. So, in this motor, very important concept, this motor is not a self-starting one. It needs some external arrangement to start a motor, because this motor produces, when we are giving the supply to a motor, it produces a pulsating magnetic field. Next, we have discussed construction. Construction of single phase induction motor. The major components of single phase induction motors are stator, rotor, shaft, end shields, bearings, frame or yoke, centrifugal switch. These are the major components of single phase induction motor. Stator means, normally stator is referred as a stationary part is called stator. Generally, stator is a laminated silicon steel core carrying main and axillary windings. Okay. Rotor means rotating part. Normally, in the induction motor, rotors are classified into two types, squirrel cage and slip ring rotor. But in the single phase induction motor, we have preferred squirrel cage type, just like a three phase induction motor. It has laminated core with aluminum or copper bar short circuited by end rings. Next, shaft transmits mechanical output supported by rotor core. Next part is end shield, which hold bearings and support the shaft at both ends. Next one is the bearings. Okay, here normally roll bearing and ball bearings are preferred. But in this type of motor, we have preferred ball bearings enabling free rotor rotation. Next, frame or yoke. Normally, yoke covers the outermost part of the, it provides the shield of the motor. It covers the outer housing that hold the stator core and dissipates the heat. Normally, yoke is constructed with the help of the cast iron steel. Next one is a centrifugal switch. In most of the types, we have preferred centrifugal switch. It disconnects the axillary winding after starting. So, these are the major core components of single phase induction motor: stator, rotor, shaft, end shield, bearings, frame or yoke, centrifugal switch. Next, let's discuss one by one deeply. First one is a stator. Stator means stationary part is called stator. The stator has a laminated construction made up of stampings. The stampings are stamped together to form a stator core. The stampings are wounded on the stator core to hold the stator winding. Normally, stator windings are called main winding, which is made up of laminated construction, which is used to reduce the eddy current loss. And also, the stator windings are made up of high-grade silicon steel, which is used to reduce the hysteresis loss. So, in order to reduce the eddy current and hysteresis loss, we have preferred laminated high-grade silicon steel stampings, which are wound on the stator core. The inner periphery, in the stator core, the inner periphery has slots that house two windings. One is a main winding, another one is an auxiliary winding. The main winding is called stator winding or running winding. The auxiliary winding is called starting winding. This winding is used only for starting purpose. In order to convert pulsating magnetic field into rotating magnetic field, we have used auxiliary winding. These two windings are placed 90-degree electrical degrees apart in space. Okay, based upon the displacement, the torque will be produced. The auxiliary winding has fewer turns of thinner wire. It has higher resistance, lower reactance than the main winding. Okay, both winding have the different magnetic properties. Auxiliary winding has higher resistance, lower reactance than the main winding. This reactance or resistance difference creates the phase difference needed for starting torque. Based upon the phase difference between the main and the auxiliary winding, the starting torque will be produced. If the phase difference is more, means more starting torque will be produced. If the phase difference is less, means less starting torque will be produced. Okay, this is the construction of the single phase induction motor. Here we have used two windings, main winding and auxiliary winding. The comparison between the main winding and the auxiliary winding. The main winding having more number of turns of thicker wire, auxiliary winding having fewer turns of thinner wire. Main winding having higher inductive reactance, auxiliary winding having lower inductive reactance. Main winding having the lower resistance, auxiliary winding having higher resistance. Main winding carries current throughout the running, auxiliary winding often disconnected after starting, which is placed in the larger proportion of stator slots, which is placed 90-degree electrical apart from the main winding. These are the major configurations of the main and auxiliary winding. Based upon the property only, we have preferred auxiliary and main winding. This auxiliary winding is mainly preferred for the starting purpose only, which is used for creating the rotating magnetic field. Because the pulsating magnetic field does not produce a starting torque, so in order to convert a pulsating magnetic field into rotating magnetic field, we have preferred starting winding with the following property characteristics. Next one is a rotor. Next we have discussed rotor. The rotor means rotating part is called rotor. Here the squirrel cage type of rotor is preferred. The squirrel cage it consists of the rotor means rotating part. It consists of the cylindrical laminated core. In order to reduce the eddy current loss, the laminated cores are consist of the copper or aluminium bars, which is acting as a rotor conductors, which are placed in the slots around the periphery. The bars are short circuited at both ends by two end rings. So this form looks like a here the bars are short circuited, which forms a closed path. Here the entire structure resembles a cage, so it got a name as a squirrel cage rotor. In this arrangement, no external electrical connections to the rotor, unlike the wound rotor, that means slip ring rotor. Here the bars are skewed. This is a skewed format, slanting format. Here the bars are skewed nature, which is used to reduce the magnetic hum and locking efforts. This type of rotor construction is simple, rugged, low cost and virtually maintenance free. For these advantages only, we have preferred squirrel cage rotor. The entire structure looks like a cage, so it got a name like the squirrel cage rotor. Okay, let's discuss other mechanical parts, that is frame or yoke. Outer cast iron or aluminium housing which supports the stator and dissipates the heat to the surroundings. Next one is end shield bolted to the frame at both ends, which house the bearings and keep the rotor centered in the bore. Next one is the bearings. Here ball bearings are preferred that let the shaft or rotor spin within the minimal friction. Next one is a shaft, the steel shaft that carries the rotor core and transmits mechanical power to the load. Next one is a centrifugal switch which is mounted on the shaft, which opens automatically at when the motor reaches 75% of synchronous speed to cut off the auxiliary winding. For this purpose only we have preferred the centrifugal switch. Last one is a cooling fan which is used for the cooling purpose in order to circulate the air over the frame for cooling. So these are the major mechanical parts of the single phase induction motor. Working principle. The working principle based on the following concept. First we are giving the supply to the single phase stator winding, which is the stator winding carries two winding, main and auxiliary winding. So the winding alone, it's a single phase stator winding alone produces a pulsating field, so which is not rotating. In order to convert the pulsating field into the rotating field, we have used auxiliary winding. By the double revolving field theory, the field resolves into two equal and oppositely rotating field. An auxiliary circuit creates an initial net torque to the rotor begins to run. With the help of the auxiliary winding, the rotor starts to rotate. Next, when the motor reaches the 75% of the speed, the centrifugal switch disconnects the auxiliary winding and also the forward field dominates and the rotor accelerates towards near synchronous speed. By this concept only, the single phase induction motor operates. Working principle. Normally, working principle is based on the two theory, double revolving field theory and cross field theory. Here we have discussed only double revolving field theory. An alternating or pulsating magnetic flux can be generated when we are giving supply to the single phase AC winding, which can be represented as sum of the two rotating fluxes of equal magnitude, such as 1/2 into pi m each. These two component fluxes rotate at synchronous speed ns in opposite direction. We have splitted into the flux components into two, forward field and backward field. The forward field rotates in the direction of the motor is mean to run. The backward field rotates in the opposite direction. Each field induces its own torque in the rotor, but the resultant torque will be the difference between the two because both are in the opposite direction. So we get the resultant torque Tf minus Tb. At standstill, we know the condition n equal to 0. Under this condition, the slip of forward field Sf is equal to 1. The slip of backward field Sb also 1. Both are having the same slip at standstill condition. So we get Tf is equal to Tb. That is forward torque is equal to backward torque. So by this condition, from this condition we get net torque will be 0. The torque will be 0 means the motor never start. Okay, once the rotor is set moving externally with the help of some arrangements, Sf and Sf become unequal. So the Tf is not equal to Tb and a net torque appears. If the net torque appears means the motor starts rotating due to the presence of the net torque. Next, working principle. The torque speed, based on the working principle, the torque speed characteristics is shown here. At n equal to 0, that is standstill condition, the curve starts at 0, that is 0 torque, which conforms here no self-starting torque. At speed rises with the external help, the net torque also increases, then falls to 0 again at when it reaches the synchronous speed ns. This is why starting mechanisms are essential for single phase motor. Okay. So here we have used various starting mechanism to start the synchronous motor. Let's start one by one. Starting methods of single phase induction motor. This leads to 4 widely used starting methods for single phase induction motor. First one is a split phase or resistance start induction motor. Second one is a capacitor start induction motor. Third one is a capacitor start, capacitor run induction motor. Last one is a shaded pole induction motor. Okay, starting methods. Okay, here the comparison of the various starting methods. We have 4 starting methods: split phase, capacitor start, capacitor run, and shaded pole. Here elements, split phase motor we have used high resistance auxiliary winding. Capacitor start we have used auxiliary winding plus capacitor. Capacitor start, capacitor run we have used 2 capacitor, that is starting capacitor as well as running capacitor. Next, shaded pole we have used shading coil on poles. Starting torque, the comparison of the 4 methods, the starting torque will be low in the shaded pole motor and moderate on the split phase motor, and high and smooth running on this capacitor start, capacitor run motor, and high starting torque will be produced on the capacitor start induction motor. It's typically used based upon the methods used in the starting methods used in the single phase induction motor. The motors are used in the split phase motors are used in the fans, blowers, and small pumps. Capacitor start motors are used in the compressors, pumps. Capacitor start, capacitor run induction motors are used in the refrigerator and high load fans. Shaded poles are normally preferred for low power applications, which is preferred for small fan, toys, and hair dryers. Let's discuss one by one. Split phase or resistance start induction motor. In this arrangements we have used main winding, and in addition with we have used starting winding. In addition with starting winding we have used centrifugal switch. Here the phase difference between the starting winding and main winding, which is represented in the phasor diagram as alpha, is based upon this alpha only. Alpha is the angle between the starting current and main current. Starting current and main current. So based upon this alpha value only starting torque will be produced. If alpha is lower means lower starting torque will be produced. Alpha is higher means higher starting torque will be produced. Normally the alpha is ranging between the 25 to 30 degree for enough for starting torque. That's alpha value is enough for creating the starting torque. Once the motor starts rotating, it continuously rotating with the help of the arrangements. So in this arrangement here, when the motor reaches 75% of the synchronous speed, by using this centrifugal switch disconnects the auxiliary winding. So the auxiliary winding is presented only on the starting time only. With the help of this centrifugal switch, the starting winding or auxiliary winding is disconnected. Here the major advantage, it is a very simple and low cost induction motor, and but moderate starting torque and high starting current. This type of motors are normally preferred for fans, blowers, compressors, etc. Okay, this is the basic arrangement of resistance start induction motor. It is a very simple arrangement. Here only we have used starting winding in addition with the centrifugal switch. When the motor reaches 75% of the speed, the centrifugal switch gets open, thereby it cut off the auxiliary winding from the circuit. Okay, next answer. The torque speed characteristics of split phase motor. As switch is on, the current flows through the both main and auxiliary winding. Okay, based upon the phase difference between the main and auxiliary current, the torque will be produced. As motor approaches 75% of the synchronous speed, the centrifugal switch opens and disconnecting the auxiliary winding. Here we get the torque speed characteristics like this. N equal to 0, the torque will be low, then the gradually increased, and N equal to Ns, it becomes again 0. Applications: these motors have low starting current and moderate starting torque. These are mostly preferred for easily started loads like fans, blowers, grinders, centrifugal pumps, washing machines, etc. Next, capacitor start motor. Okay, it is same as that of split phase motor. In addition with it, we have used one capacitor. Okay, this capacitor creates the much larger phase angle. That is, here the alpha is more compared with this alpha is more compared with the split phase motor. In order to increase this alpha value only, we have used here capacitor. So the capacitor creates much larger phase angle. Okay, in the split phase motor we get the phase angle approximately 25 to 30 degree, but in the by using this capacitor we get the phase angle 80 to 90 degree. So if the phase angle is more means we can get the high starting torque. So we can get the high starting torque than the split phase motor. Here only used in addition with we have used capacitor only. So this capacitor is the starting winding is disconnected with the help of centrifugal switch when the motor reaches 75% of synchronous speed. Using this type of motors have high starting torque, so it is preferred for compressors, pumps, conveyors. This is a basic symbolic representation of capacitor start motor. It is same as the split phase motor. Here in addition with we have used one capacitor only. Here the alpha is more compared with the split phase motor. Capacitor start motor working. Here in capacitor is series with the auxiliary winding which causes its current IA to lead the supply voltage. So the main winding current IM lags the supply voltage. This produces the phase difference closest to 90 degree. Here the phase difference between the IM and IA is alpha. This alpha reaches nearly approaches to 90 degree between IM and IA, which approximately using the two phase operation at start. A strong RMF is created giving 3 to 4.5 times the starting torque of a split phase motor. Once the motor running near the synchronous speed, the centrifugal switch opens and disconnects the capacitor and auxiliary winding. The motor continues to run on the main winding only like a plain single winding induction motor. Okay, this shows the torque speed characteristics of the single phase induction motor. Next we have discussed capacitor start, capacitor run induction motor, which is same as the capacitor start motor. Here in our centrifugal switch is not present. That means here the capacitor resistance remain in the circuit during the starting as well as running condition. Here we have uses two capacitors. One is a start capacitor having the value high value short duty, and a run capacitor having the low value and continuous duty. Start capacitor switched out by centrifugal switch after starting like a capacitor start type. Run capacitor stays in the circuit permanently, which improves the power factor, efficiency and running torque, which delivers high starting torque and smooth efficient running, the best performing single phase design. So which makes it costlier because and more complex, which is used in the refrigerator, compressors and high performance fans. So by using this capacitor remains in the circuit, we can get the power factor improvement. That's the main advantage of this arrangement. The direction of rotation in both types can be changed by interchanging the connection of main winding and auxiliary winding. The capacitor permanently in the circuit improves the power factor. These motors are more costly than the split phase type. The capacitor value can be selected as per the requirement of starting torque. The starting torque can be as high as 350 to 400% of the full load torque. Next, permanent split capacitor motor. Already we have discussed. Here no centrifugal switch, auxiliary winding and capacitor remain in the circuit, so continuously during running. The value of single capacitor is a compromise between the best starting torque and best running performance, and also here low starting torque than the capacitor start, capacitor run, but simpler and cheaper, which is popularly preferred in fans, small blowers, etc. These motors are available up to 6 kW used in the capacitor start motors. Last one is a shaded pole motor, which is the simplest single phase motor, which has salient poles. This is a salient poles. Salient pole means projected poles instead of a distributed stator winding. Here each pole is split. A small portion is encircled by a short circuited copper ring called the shaded coil. Here no auxiliary winding, capacitor or centrifugal switch. So the construction is extremely simple and rugged, but it produces the low starting torque and low efficiency, but is very inexpensive and reliable. This type of arrangement is mostly preferred for low power applications such as small fans, exhaust fans, hand dryers, record players and other light duty applications. Here, the working principle: as flux in the shaded pole areas rises, it induces current in the shading coil that opposes the flux change according to Lenz's law. So, it delaying the flux build up in the shaded portion. As the main flux falls, the shading coil current reverses and now sustains flux in the shading portion a little longer. Net effect: the flux under the shaded part of the pole lags the flux under the unshaded part. This time lag effectively sweeps the magnetic field across the pole face from unshaded to shaded. This shifting field acts like a weak rotating field, dragging the rotor along, which giving the low but sufficient starting torque. So this type of motor giving the low power, low starting torque, and also it is preferred for low power application such as small fans, toys, etc. This table gives the comparisons of the starting methods, which is already discussed, but the rating of the motor starting is here. Split phase is rating is up to 5.5 horsepower. Capacitor start is preferred up to 3 horsepower. Capacitor start, capacitor run is preferred up to 5 horsepower. Shaded pole is only fractional horsepower. Already we know which is preferred for low power applications. Cost, the cost is very low in the shaded pole, but low in the split phase, moderate in the capacitor start, but high in the capacitor start, capacitor run, induction motor. Efficiency, we are comparing these four methods, best efficiency is obtained from the capacitor start, capacitor run, induction motor. Starting current, the starting current is high in the split phase induction motor and low in the shaded pole induction motor. This is the table gives the comparison of various starting methods under starting torque, starting current, efficiency, cost and typical rating. Next, applications. Normally single phase induction motors are preferred in the most of the home appliances, ceiling and table fans, washing machines, refrigerator, compressors, water pumps, air conditioners, mixer grinders, hair dryers, small boilers, vacuum cleaners. But various types of induction motors are preferred for various applications. In the washing machine, we have used capacitor start induction motor. In the refrigerator, we have preferred capacitor start, capacitor run induction motor. Hair dryers, we have preferred shaded pole induction motor. In the air conditioners, we have preferred capacitor start, capacitor run induction motor. Okay. Advantages and disadvantages of induction motor. Advantages, it operates directly on widely available on single phase domestic supply, compact and economical for low power rating, wide range of starting torque options to match the load, and also it provides quite reliable operation across many designs. Next, disadvantages, which gives lower efficiency and power factor than the 3-phase motor, and low power rating, generally limited to fractional low horsepower, higher torque pulsations compared to the polyphase motors. Thank you.